Welcome to Module 5, Data Privacy, Data Governance, and Responsible Data Use in AI. In this module, we begin from a simple but powerful idea. Artificial intelligence is never separate from the data that makes it possible. Every model that recognizes a pattern, generates a prediction, recommends an action, or supports a decision is shaped by the information it has been given and by the conditions under which that information was collected. So when we talk about responsible AI, we can't limit the conversation to algorithms, accuracy, or technical performance, because the ethical questions begin much earlier. At the moment data is gathered, selected, stored, interpreted, and reused. The purpose of this module is to slow that process down and examine what responsible data practice requires before an AI system ever reaches deployment. Throughout the lesson, that theme will remain at the center of our analysis. Data privacy matters because AI systems often work with information that is deeply connected to real people, real organizations, and real communities. That information may include personal identifiers, behavioral traces, medical histories, financial records, images, location patterns, workplace activity, educational records, or other forms of data that reveal more than users may realize. In many cases, the value of AI comes from combining and analyzing these data sources at a scale no individual person could manage manually. But that same scale creates risk because patterns that seem harmless in isolation can become sensitive when they are connected, inferred, or used to make decisions. For that reason, privacy in AI is not only about hiding a name or removing an obvious identifier. It is about understanding how data can expose, classify, predict, and affect people in ways they may not expect. Data governance gives organizations a structured way to manage those risks rather than treating them as afterthoughts. Governance includes the policies, procedures, roles, and oversight mechanisms that determine how data should be collected, who can access it, how long it should be retained, how it should be protected, and under what conditions it can be used for AI development. In a mature organization, governance is not merely a compliance checklist completed at the end of a project. It is part of the design environment, shaping decisions about data quality, consent, security, accountability, and responsible use from the beginning. When governance is weak, even technically impressive AI systems can become ethically fragile because no one has clearly established the boundaries for acceptable data practice. Responsible data use also requires us to recognize the tension between data utility and privacy protection. Larger and richer data sets can improve model performance by helping systems detect subtle patterns and generalize across different situations. At the same time, collecting more data than necessary can increase exposure, make misuse more likely, and deepen the consequences if the data is breached, misunderstood, or applied inappropriately. This tension does not have a single universal solution because different AI systems involve different purposes, populations, and levels of risk. What matters is that organizations make deliberate choices about necessity, proportionality, protection, and accountability, rather than assuming that more data is automatically better. As we move through the module, I want you to listen for the connection between technical decisions and ethical responsibility. A data set is not just a neutral input. It reflects decisions about whose information matters, which variables are included, which contexts are ignored, and which outcomes the system is designed to optimize. These decisions can influence whether an AI system is useful, fair, secure, and trustworthy. They can also determine whether individuals and communities experience AI as a tool that supports better decisions, or as a system that extracts information without adequate transparency or control. This is why privacy and governance are central to responsible AI, not peripheral concerns added after the technology is built. By the end of this module, you should be prepared to discuss data as both a technical resource and an ethical responsibility. You should be able to explain why data is essential for training and deploying AI systems, analyze the implications of large-scale data collection, evaluate privacy risk in AI-driven processing, and assess governance strategies that protect individuals and organizations. More importantly, you should be able to think critically about how these ideas fit together in real AI development. Responsible AI depends on more than building models that work. It depends on building systems whose data practices can be justified, governed, and trusted. That is the foundation for everything we will examine in Module 5. In this part of the module, we focus on the role that data plays in both training and deploying artificial intelligence systems. An AI system may appear to operate through code, formulas, or model architecture, but its practical intelligence depends heavily on the information it has been exposed to. Machine learning models learn by identifying patterns within data sets, and those patterns become the basis for prediction, classification, recommendation, generation, or decision support. When the data is rich, relevant, and well prepared, the model has a stronger foundation for learning useful relationships. When the data is incomplete, poorly organized, outdated, or biased, the model can still produce outputs, but those outputs may be unreliable or ethically problematic. Training data is the material from which a model learns its internal representation of a task. During training, the system is not being given human understanding in the ordinary sense. Instead, it is adjusting mathematical relationships so that certain inputs become associated with certain outputs. If the task involves predicting home prices, the model may learn from historical records about square footage, location, number of rooms, and sale price. If the task involves detecting disease from images, the model may learn from labeled medical scans and associated diagnoses. Across these examples, the central idea is the same. The model's behavior is shaped by the patterns available in the training data, so the quality and relevance of that data directly influence what the system can learn. The types of data used in AI can vary widely, and this is one reason responsible use becomes so important. Some datasets include information that seems routine, such as product ratings, website activity, or transaction histories. Other datasets may include personal information, behavioral records, images, financial data, or medical records, all of which can be highly sensitive. Once these data points are used to train a model, they may influence future decisions in ways that are difficult for individuals to see or challenge. This means that data is not merely a technical input. It can represent human lives, vulnerabilities, opportunities, and risks. Responsible AI therefore requires careful attention to what kinds of information are being used and whether that use can be ethically justified. High-quality data helps models identify meaningful patterns rather than noise, coincidence, or distortion. Quality includes accuracy, completeness, consistency, representativeness, and suitability for the task the model is expected to perform. A dataset can be large and still be weak if it excludes important populations, contains inaccurate labels, or reflects conditions that no longer apply. In graduate-level AI work, it's important to avoid assuming that more data automatically produces better intelligence. Larger datasets can improve performance, but only when the data is relevant, responsibly collected, properly governed, and appropriate for the model's intended use. The responsibility of the developer or organization is to ask whether the data genuinely supports the decision the system is expected to make Data also matters after training because deployment introduces a new set of decisions and risks. Once an AI system is placed into use, it may process new information from users, customers, patients, employees, applicants, or members of the public. That incoming data can shape individual predictions, update system behavior, trigger automated actions, or support organizational decisions. A model that performed well in a controlled training environment may behave differently when it encounters real-world data that is messy, incomplete, or different from what it saw before. For that reason, responsible deployment requires ongoing monitoring, data validation, and attention to whether the system continues to operate appropriately in its actual context. This is why the role of data must be understood across the full AI lifecycle. Data is involved when the problem is defined, when the dataset is collected, when features are selected, when the model is trained, when performance is evaluated, and when the system is deployed. At each stage, decisions about data affect both technical outcomes and ethical consequences, including who benefits from the system and who may be placed at risk. If an organization treats data only as fuel for performance, it may overlook privacy, consent, security, fairness, and accountability. But if the organization treats data as a managed responsibility, then AI development becomes more careful, more transparent, and more aligned with the interests of the people affected by the system. In that sense, responsible data use is not an optional addition to AI. It is one of the conditions that makes trustworthy AI possible in practice over time. 2. Large-scale data collection sits at the center of many modern AI development practices because models often improve when they have access to broader, richer, and more varied information. Organizations collect data from transactions, devices, platforms, sensors, records, and user interactions because those data points can help systems identify patterns that would otherwise remain hidden. From a technical perspective, this can make an AI system more accurate, adaptable, and useful across different cases. But the ethical question begins when we ask how that information was obtained, whether people understood the collection process, and whether the purposes were clearly communicated. Data collection may support better performance, but performance alone cannot justify every data practice. Consent is one of the first ethical concerns that appears in large-scale AI data collection. Individuals should know when their personal information is being collected and how it may be used, especially when the data could shape decisions about them later. In practice, consent is often complicated by long privacy policies, unclear platform settings, secondary data use, and data sharing arrangements that most people never fully understand. A person may agree to use a service for one purpose, while their information later becomes part of a training dataset, a behavioral profile, or an automated decision system. That gap between formal permission and meaningful understanding is one reason consent must be treated as more than a checkbox in responsible AI development. Transparency is closely connected to consent because people cannot make informed decisions if the collection process is hidden or difficult to understand. Organizations may collect large volumes of data in ways that are technically legal but still ethically troubling if users do not know what is being gathered, why it is needed, or how long it will be retained. Transparency requires more than announcing that data is collected. It involves explaining purposes, risks, limitations, and potential downstream uses in language that affected people can reasonably understand. In AI development, this is especially important because as data can be repurposed, combined with other datasets, and used to generate inferences beyond the original context. When transparency is weak, trust becomes fragile, and that people affected by AI systems may feel that decisions are being made through processes they cannot see or contest. Large-scale collection can also create unintended consequences for individuals and communities. A dataset may contain patterns that reflect social inequality, unequal access to services, or historical decisions that were never neutral to begin with. If those patterns are collected at scale and used to train AI systems, the model may reproduce or intensify existing disparities while appearing objective because it is data-driven. Communities can also be affected when data about neighborhoods, schools, health outcomes, policing, employment, or credit access is used to classify risk or allocate opportunity. The ethical concern is not only that a single person's privacy might be violated, but that entire groups may be represented through data practices they had little power to shape. Another important issue is proportionality, which asks whether the amount and type of data collected are actually necessary for the AI system's purpose. Organizations may be tempted to collect everything available because future uses are uncertain and more data seems valuable. Yet collecting excessive information increases the possibility of misuse, unauthorized access, surveillance, and harms that emerge after the original project begins. Responsible data practice requires a disciplined assessment of what information is needed, what information is too sensitive, and what safeguards must be in place if collection is justified. Ethical AI development therefore involves restraint as well as innovation, because not every technically useful data point should automatically become part of a model. Ethical review helps organizations resist the tendency to prioritize performance alone. A model that performs well on a benchmark may still be irresponsible if the data behind it was collected without adequate consent, transparency, security, or consideration of social impact. Review processes should ask who benefits from the collection, who carries the risk, whether affected people have meaningful notice or control, and whether the organization can justify the relationship between the data collected and the system being developed. These questions do not reject AI innovation. Instead, they help ensure that innovation is pursued within boundaries that respect individuals and communities. In that sense, large-scale data collection must be evaluated not only by what it allows a model to learn, but by whether the collection itself can be defended as responsible, fair, and transparent. AI-driven data processing creates powerful opportunities for organizations, but it also changes the privacy risk environment. When an AI system processes information, it is not simply storing records in a passive database. It is searching for patterns, building relationships, generating classifications, and sometimes producing inferences not explicitly present in the original data. Sensitive information can be exposed not only through what a person directly provided, but also through what the system is able to infer from behavior, images, transactions, medical details, or personal records. This is why privacy risk in AI must be evaluated at the level of processing, not only at the level of collection. The danger often emerges when data moves through analytic systems that can reveal more than the dataset appears to contain. One serious concern is that large datasets increase the possibility of privacy loss. The larger and more detailed the dataset becomes, the more likely it is that individuals can be identified, profiled, or linked across contexts, even when obvious identifiers have been removed. A record that seems anonymous in one setting may become identifiable when combined with location patterns, purchasing behavior, demographic details, or other digital activity. This matters because AI systems often depend on those connections to generate useful predictions. The same pattern detection that makes the system effective can also make the system intrusive. Responsible AI therefore requires organizations to ask whether processing may reveal sensitive personal or behavioral information that people did not intend to disclose. Surveillance is another major privacy risk, because AI processing can turn ordinary data streams into continuous monitoring systems. Information from cameras, devices, apps, workplace platforms, public records, or online behavior can be analyzed to detect habits, movements, associations, preferences, and perceived risks. In some contexts, monitoring may be justified for security, safety, or service improvement. But the ethical problem arises when surveillance expands beyond what people reasonably expect or can meaningfully control. AI intensifies this concern because it can process large amounts of information quickly and make automated judgments from patterns that individuals never see. When organizations rely on these judgments, privacy becomes connected to autonomy, dignity, and the ability to participate in society without being constantly classified. Misuse deserves separate attention because data collected or processed for one purpose can later be used for another. Financial records gathered to assess eligibility, medical information used to support diagnosis, images collected for identification, or behavioral data used to personalize a service can all become harmful if they are accessed by the wrong people or applied in inappropriate ways. Even well-intentioned organizations create risk if they lack controls over who can use the data, how it can be shared, and whether secondary uses require review. In AI development, misuse may also occur when sensitive information becomes part of a model in ways that make future outputs difficult to trace. Once data has influenced the model, it may be hard to separate the original record from the system's later behavior. The consequences of privacy failures can affect both individuals and communities. For an individual, exposure of sensitive data may lead to embarrassment, discrimination, financial harm, loss of opportunity, or reduced control over personal information. For a community, AI processing can reinforce unwanted visibility, label certain groups as risky, or make decisions based on patterns that reflect social vulnerability rather than individual conduct. These harms are especially serious when the data involves financial status, medical conditions, personal images, family circumstances, or other records that carry institutional consequences. Privacy is therefore not only a matter of secrecy, it is also a matter of power, because whoever controls data processing may influence how people are understood, evaluated, and treated. Organizations have a responsibility to protect sensitive information during both development and deployment. This includes careful storage practices, access controls, security safeguards, retention limits, review of data sharing, and attention to how information is used after the model is placed into operation. Protection cannot end when the training phase is complete, because deployed AI systems continue to receive, process, and generate data in real environments. Responsible processing requires organizations to document who can access information, why access is necessary, how risks are monitored, and what procedures exist if something goes wrong. Privacy protection is not a single technical feature. It is a continuing governance obligation that follows the data throughout the AI lifecycle. Data governance gives organizations a practical structure for protecting people, institutions, and the integrity of AI systems. When we discuss governance, we are talking about the policies, roles, procedures, and oversight mechanisms that guide how data is collected, stored, accessed, shared, retained, and used. In AI development, this matters because data moves through many stages before it produces an output that affects someone. A dataset may begin as customer activity, patient records, financial histories, images, or operational logs, and then it may be cleaned, labeled, combined, analyzed, and used to train or deploy a model. Without governance, each stage can become a point where privacy, security, fairness, or accountability breaks down. One of the first responsibilities of data governance is to ensure that data is collected ethically. Ethical collection means that organizations should have a legitimate purpose for gathering information, should communicate that purpose clearly when possible, and should avoid collecting more data than the system reasonably needs. This is important in AI because the pressure to improve performance can encourage broad collection practices that are difficult to justify. Governance helps create boundaries around that impulse by requiring review before sensitive data sets are used. In this way, governance makes innovation defensible by connecting technical work to responsible decision making. Governance supports secure storage because data protection does not end once information has been collected. Sensitive data must be stored in environments that limit unauthorized access, reduce breaches, and preserve the confidentiality and integrity of records. This may involve access controls, encryption, audit logs, retention schedules, and clear rules about who may use the data and for what purpose. In an AI project, these practices are important because datasets may be copied, transformed, or shared across teams. If storage practices are weak, even a well-designed model can be built on a foundation that exposes people and organizations to unnecessary risk. Appropriate use is another central part of governance. Data that was collected for one purpose should not automatically be treated as available for every future AI application. A university, hospital, bank, employer, or public agency may have access to information that is useful for modeling, but usefulness alone does not establish ethical permission. Governance requires organizations to ask whether the proposed use is compatible with the original context, whether affected individuals could reasonably expect that use, and whether additional protections are needed. This is where governance becomes a bridge between legal compliance and ethical judgment, because it helps organizations think beyond what they can do. Oversight mechanisms are important because responsible data use cannot depend only on individual good intentions. Organizations need review boards, data stewards, approval workflows, risk assessments, incident response procedures, and accountability structures that make data decisions visible and reviewable. These mechanisms reduce risk for individuals by helping prevent careless exposure, inappropriate access, and harmful secondary use. They also protect institutions by creating records of decision making, clarifying responsibilities, and reducing the chance that an AI project will create legal, reputational, or operational harm. When oversight is taken seriously, governance becomes a living process rather than a document that sits unread after approval. Effective governance aligns AI development with privacy, responsibility, and ethical practice. That alignment matters because AI systems are data intensive by design, and data intensive systems can amplify small failures into large consequences. A poorly governed data set may affect model quality, privacy protection, fairness outcomes, and public trust at the same time. By contrast, a well-governed data set gives developers, leaders, and stakeholders a stronger basis for asking whether the system is appropriate for its intended purpose. In that sense, data governance is not separate from AI performance. It is a part of the conditions that allow performance to be trusted. As you evaluate governance strategies, focus on how they protect both individuals and organizations. Individuals need protection from exposure, misuse, surveillance, and decisions made with data that should not have been used. Organizations need protection from unmanaged risk, unclear responsibility, security failures, and systems that cannot be explained or defended when challenged. Strong governance brings these interests together by creating rules for responsible collection, secure storage, appropriate use, and continuing oversight. For responsible AI, the goal is not to remove data from innovation, but to make sure that data is handled with the care that its power requires. For this final slide in the module, we turn to one of the most difficult questions in responsible AI. How should organizations balance the usefulness of data with the need to protect privacy? AI systems often perform better when they have access to large, detailed, and diverse data sets. More data can help a model recognize patterns, reduce uncertainty, improve accuracy, and make predictions that are useful in real settings. From a technical perspective, it is easy to understand why organizations want as much information as possible. But responsible AI requires us to ask a second question at the same time. What risks appear when that information becomes more detailed, sensitive, or widely accessible? Data utility refers to the value that data provides for a specific purpose. In AI development, useful data helps a model learn relationships that matter for the task it is designed to perform. A healthcare model may need enough clinical variation to recognize patterns across different patients. A fraud detection model may need examples of normal and suspicious transactions. A recommendation system may need behavioral patterns in order to produce relevant suggestions. In each case, the data has utility because it supports the system's intended function. Yet utility is not unlimited permission, because the fact that data may improve performance does not automatically mean it should be collected, retained, or processed without restriction. Privacy protection places limits around how data can be gathered and used so that individuals are not unnecessarily exposed to harm. These protections may include collecting less data, removing unnecessary identifiers, restricting access, limiting retention, securing storage, reviewing secondary uses, or designing systems that reduce the need for sensitive information. The purpose is not to prevent AI systems from working, but to make sure they work within ethical boundaries. Privacy protections recognize that data can reveal personal circumstances, behavioral patterns, medical conditions, financial stress, relationships, and vulnerabilities. When those details are used carelessly, the harm may become discrimination, surveillance, loss of autonomy, or loss of trust. The challenge is that data utility and privacy protection can sometimes pull in different directions. A model may become more accurate when it receives more features, more records, or more detailed histories. At the same time, each additional data point may increase the risk of misuse, exposure, or inappropriate inference. This does not mean organizations must choose between effective AI and ethical AI. It means they must define what level of data is necessary, proportionate, and defensible for the intended purpose. Responsible practice asks whether a smaller data set, a less sensitive feature set, stronger aggregation, or stricter access control could achieve the system's goals while reducing risk. This balance should be evaluated in relation to context. Not every AI application carries the same level of privacy concern. A model that predicts inventory demand using product sales data may raise different issues from a model that processes medical images, financial records, student performance data, or employee behavior. The more sensitive the information and the more consequential the decision, the stronger the privacy protection should be. Organizations need judgment, governance, and ethical review to determine whether the benefits of using certain data outweigh the risks imposed on the people represented in that data. Balancing utility and privacy also requires organizations to resist the assumption that more data is always better. More data may improve performance, but it may also introduce noise, outdated patterns, security burdens, and ethical exposure. In some cases, a carefully selected, well-governed dataset may be more appropriate than a massive dataset collected without clear boundaries. The responsible question is not how much data can we obtain. The better question is, how much data do we need? For what purpose? Under what safeguards? And with what accountability? That shift in thinking moves AI development away from extraction and towards stewardship. As we conclude this module, the broader point is that responsible data use requires deliberate trade-offs. Organizations should support AI performance, but not by treating privacy as an obstacle to be minimized. Privacy protection is part of what makes AI trustworthy, because people and institutions are more likely to accept systems when they believe data is handled with care and accountability. The goal is not to weaken AI, but to build systems whose effectiveness does not depend on unnecessary exposure or irresponsible collection. When data utility and privacy protection are balanced thoughtfully, organizations can pursue innovation while respecting communities whose information makes that innovation possible.